In this video, I'm going to show you the SPC features in the QRM web application. SPC stands for Statistical Process Control, and this is a method to try to determine if your measurement process is stable and in control. I'm going to use the AddQ4 demo server, and there's always some measurement available at that place. So first I select the UT type, then I select one numeric result to analyze. I'm going to start with the play voice amplitude. I press execute, and then we'll see all the measurement values will be fetched. We have about 560 values, and we can see that we actually have one dead measurement here. And SPC can't not use any dead values. We need to remove them to have a correct SPC analysis. So we can use the automatic outlier removal in QRM. There we go. And here are all the individual measurements we can see here. Here's a nice histogram, and we can see that values are centered around 155 here. If I click a graph, it will zoom. We can see that the green line here is the average, same value as the center of the histogram, of course. The upper red bar here is 3 sigma, 3 standard deviations to the top, and down here is 3 standard deviations below the mean, and the yellows is 1 sigma, 2 sigma. And we know if the process is normally distributed that 99.76% of all values should be between the upper control limit plus 3 sigma and the lower control limits minus 3 sigma. So down here we have the moving range. That is actually the difference between each sample here, and you can see this is quite nice, no big steps and so on. And down here we have the last 25 samples. That is actually zoom of the last 25 samples here, and it could be quite nice to see if you have any pattern or something that is quite difficult to see here. And if you think that this view looks quite familiar and you're used to work with Minitab, you will see that it's the same abbreviation, same layout, same colors, everything that Minitab has. This is the normal probability plot. This will actually show a straight line if your values are normal distributed. Down here we have some calculations. We have the standard deviation, both for the within and the overall. And the difference between within and overall is the way to calculate the standard deviation. The overall is calculated as the formula you probably know from the statistics course, where you take the absolute value of the distance between the mean and the measurement value and square it and sum, and then take square root. And the within is calculated, the standard deviation is calculated based on the moving range and used as an estimator. 2 ways of calculating the standard deviation. And why do they differ? And you can actually see that from this curve here, because this bell shape here, the black one, that's called the overall, based on this standard deviation, and the within is based on this. And you can see this is slightly smaller, making the shape a bit larger. And if these 2 curves differs, that means that this one and this differs. And if they differ, that means that you have something like this. You have a quite moving range chart that doesn't show much, but you have something that is going with a long envelope way like this. And that the within says that you have a quite good process in the short term, but the overall is worse because you have things that tend to vary in the long run. When you can analyze this graph here, you can see there's a lot of red dots here and some yellow, and that's actually some warnings that called the Weko warnings and the Nelson warnings. So if I scroll down here, we get a nice analysis of the process summary. We can see the amount of data. We can see the p-values for the Anderson-Darling and the Shapiro-Francia goodness of fit tests. But we also see the Weko rules warnings. And the Weko rules are the Western Electric rules, and they are searching for unexpected patterns in your data. So the Weko rule called 1, that is just if any single data point falls outside the 3 sigma limit from the center line, and we have 3 warnings of that. And the Weko warning 2 and 4, we have most of them. And like the Weko warning 4 is 8 points following each other falls on the same side of the center line. And we can typically see that we have a lot of warnings here because they are all above the mean, and here it's better. So there's a lot of warnings here, but that's because of this slow shifting bias, and we shouldn't have that many warnings. So it's really good to have, and you sort of expect some false alarms. With the more data you have, the more false alarm you have. So use the Weko warnings as a guide, a hint, and do not take them too seriously. And next I'm going to show you is the capability. And until now, what we're talking about has only been analyzing things without limits. But when you talk about the lower specification limit and the upper specification limits, we're talking about the process capability to fulfill your requirements. And in the histogram, you can see the limits here and here. And down here, we can see the calculation called CP and CPK. And the CP is really simple to calculate and really useful. The CP is actually just the distance between the upper specification limit minus the lower specification limit divided by the distance of plus minus 3 sigma, this distance. So in this example we have CP of about 4, and that means that this distance divided by this distance is about 4. That's correct. The CPK also includes if this histogram or process is centered. So if this curve would be in the center here, exactly in the middle between the upper specification limit and the lower specification limit, the CPK would be identical to CP. So the CPK can only be as high as the CP or lower. And if we go down here, we also get the analysis of the capability. So we can see that we have a CP of 4, should be above 1, of course. And then we have the CPK 3.17. That's a good CPK, but as long as it's not the same as the CP, we can do a little bit more to center the process mean to the limits. And here we can see that we reach 6 sigma level 6. We have a CPK of more than 2, and we will have almost no fails in this test except for dead units, as we saw. And at the bottom here we have a really useful tool, is that sometimes when we don't really know what limit to use, that's typical scenario, we can let QRM backward calculate the limits. So if I want the CPK exactly of 1.33, I should use these limits. If I want a higher CPK, I have to be a bit more generous with the limits, and this would be the one. You can of course also download the data to as a CSV file. If I click here, I can open it with Excel, get the values directly here like this. I can also download them to a PDF. All the graphs, open, and here you have the same report as a PDF.